Okay, hello everyone. It's been a while since the last time we met, and today, this episode gonna be the first one that we're gonna talking about the data structure part of this course, CPE213, algorithm design. So first of all, I would like to recap the the overall and generic concept of the data structure for you guys. Okay, so first of all, what is data structure? If you look at the definition itself, it's going to be quite clear that the data structure should have been something that related to how to define a collection of the data object. Okay, so it doesn't have to be the same type of variable, since from the project that you have done, and I think you have learned much more of the programming class during a years around a years that we didn't met. So the data object itself is can refer to every single things, mostly in C that you have learned, or in even in Python, it's going to be created in terms of struct, right? And under the struct itself, it can have integer, string, and any other type of data that you design for a specific type of function. Okay, so basically, it's created for storing and managing the data that you're going to be used. However, it have to be designed to be fit with the function it's going to be used. And it's depend on the field that you're going to use. If you're going to create AI, if you're going to create the graphic operand, or you're going to do something with the OS itself, it's going to have many issues that we're going to touch a lot in this class about the complexity in algorithms. Whenever you change the algorithms, you need to change, or maybe not have to be changed, but redesign data structure that you're going to use, simply because it's going to affect the performance of your code. We're going to learn how to calculate in mathematical way to prove that your algorithms going to be faster in theoretically sense, that it should be faster in most of the case, since the algorithms nowadays doesn't have like the fixed structural. If you learn from the news or you study by yourself, a lot of AI itself does something that we call heuristic search, which is use probabilistics function. Simply mean by chance the AI is gonna find the solution, but it doesn't have like fixed state of the operation that okay, they have to do this loop for 100 times. Every 100 times they're gonna find a solution. No, it's not anymore. Every single time, every single iteration, AI is gonna have a chance like 70% or 75% chance that they're gonna find the solution for some specific problems. So it's gonna be a little bit harder in nowadays to calculate or estimate how algorithms gonna be run, and also how long it's gonna take. But we can use some mathematical function to estimate the average performance or average calculation times that it's gonna be used. Okay, so the index that we gonna care mostly in this class is for sure gonna be speed, and the processing speed have to be compared relatively to the other competitors in the same environment. In the same environment is mean in the same PC, in the same computational function, in the same RAM, in the same setup. Okay, it's extremely hard that you say okay, you run your algorithm in your computers and it takes just 1.2 seconds, and I run in my PC, which is used for my research, and it have like high performance computing, and it can run in just like 300 milliseconds, then you cannot directly compare the speed by times. But it's like within one same environment. For example, like I have two code, one implement by you, another implement by your friends, and I want to compete the speed. I have to compete in the same setup, in the same PC, in the same proper RAM, CPU, and if you use the network, so it have to be the same internet speed as well. Okay, but another way around, we're gonna asking about how many iteration of your code, how many times that the loop have to be run in general, or even calculate it mathematically into big O number or whatsoever, which is we're gonna learn later on. Okay. The second thing is the optimum use of resources. Simply means that you design or selected data structure that fit with your question and concise enough. You doesn't lose too many bits of memories, or you doesn't lose the speed by making it too bulky, for example. Okay, and I don't think like this one gonna be used in this class since it's related to simultaneous requests. Okay, but just keep it in mind that in the future, in the database class, you need to consider this as well, since different type of data structure also, how I would say in general, it doesn't mean that different type of data structure gonna have different runtime. So the faster one gonna be easier to access by many people in the same time. It's not gonna be that simple in the database world, especially when you're talking about like 1,000 people access to the same memory at the same time. So you need to design the way to run the order. But this one, I would say generally you're not gonna find much in this class. Okay. Okay, the last one is memory usage. For sure, your structure have to be concise, and the size of it should be compromised with the performance as well. So sometimes you can say like, okay, I made it a little bit bigger than my friend, but it's made my code can be run like a little bit faster. So that's a little bit of trade-off that we can talking about by the limitation of the problem solution that we would like to see. Okay. And the last one is going to be reusability. So each specific data structure should be reusable in the same context or in the same algorithms. We're going to talk about it later on. Okay. The abstraction, for sure, this one is like the most generic concept. If you abstract down your structure well enough, it's going to be able to reuse. So the reusability and abstraction is going to be two things that tied it to each other. It cannot be separate that much. Okay, so this is like the most generic concept of data structure. However, if we're talking about the most basic one, and I want to recap it again, especially in C, okay? In C, I mean, in this class, you can use C, Python, whatever that you want, but especially in C that you can directly access to the memories, you need to understand and like, you know, like wear around, remind of this concept all the times, that every single data point in your code have three main elements. Rather than that, it cannot be accessed in RAM. Okay, first of all, it need to have address. Why? Because we have to know where it is in your RAM. Okay. Second is the value of that specific variable, and the last one is the name, which is kind of nickname of this address number. We're gonna talk about it in detail later on in some specific languages. These two is kind of replaceable terms. Okay, but however, like you need to have like 3 elements. Rather than that, you cannot access your data in RAM or in hard drive. Okay, why? We need to come back to basic that RAM itself. Okay, if I would like to change the color a little bit. Okay, RAM itself is stand for random access and memory. Okay, then you might ask why it have to be random. Long story short, it's made the memory can be a lot faster in terms of when you read the data out of the memories, and the read speed is something that crucial to the performance. Okay, whenever you store the data in, you need to read it as fast as possible if you want to run the code as fast as you want. Okay, then the random access itself is mean that generally speaking, from like line 1 of code 2 and 3, you might declare 3 or 4 different variables. You might declare y, x, c, 3 different variables, which is equal to, I don't know, like maybe characters, a number, a floating point. Okay, but each of them not store in this specific order in RAM. No, it's not going to do that. So basically, like an anomaly, what it's going to do is that the number 1 might go here, but number 2 stand around here, and number 3 might be like at the end of the memory. Okay, it's randomly selected the space that is as fast as possible go to access in RAM, and then store it immediately whenever the code run. Okay, that's what the hardware did. And then in the same time, it means that your memory is like balabalani, like no, that's Japanese, like it's like go all over the place in general, and without the address you might not know where it is in the memory. And that's why the address itself normally store in the 16 or hex, oh no, it's not hexatron, like never mind, is gonna be 16 base digit. Normally it's gonna encode in that way. Okay, but nowadays it can be, I think like normally it's gonna be 16 base digit, but in 32-bit system or 64-bit system, it's gonna be 3 number in a row, and then you cut out and change it into 64-bit. That's gonna be like something in detail that we might be able to talk later on if we have time, and if you're interested to deep dive into how memory allocation is gonna work and how it affect your memories. But basically speaking, this stuff mostly affect the people who work with low-level programming more than high-level programming, because you cannot access that address directly in Python, not be able to do that in R or in Golang or web programming. You cannot do that. But if you implement something in C, and also all of the C archetype, it's going to be useful, and it's going to help you a lot in how you manage the little bit amount of memories, especially people who work with embedded system that they have limited RAM in the microcontroller. Okay, then you can minimize how the memory is going to be allocated all over the place. Okay, so what we have to talk about, like the first one of all in data structure, is have to be array. Okay, so this one this episode is going to be introduction, and in the same time I'm going to talk about the array and limitation of it as a recap of it. Okay, and after episode about the recap stuff, it's going to be one by one of each like generic data structure like linked list, queue, stack, and whatsoever. I'm gonna make it like 10 minutes each or 15 minutes each around that for one video as a recap and push it in YouTube channel. Okay, so first of all, if you look at the array and the definition of it is a fixed size. Okay, there are one big keyword here: fixed size, sequential collection of data. So it have to be like two things, okay, fixed size and sequential. And how it's going to be look like in the memories is that if you declare a of array A of size 10, okay, what it does is allocate the first address in memory, okay, and then what happens later on is that it's gonna sequentially store the same size of memories in specific number. Okay, in this one is gonna allocate 10 block of memories, okay, from n equal to 0 to n equal to 9 if n itself refer to array index. Okay, normally we're gonna call it index of the array, and the size of array that you allocated here is gonna be equal to data type here. Okay, so how array works is basically you can store as many data as you want that you predefine. Okay, at the first place, this is the data that you predefine. So you need to declare the size, you need to declare size, you need to declare data type, and then compiler can allocate the space in your memories by store only the first address in the memories, and then allocate the memories equal to the size of data type multiply by array size is equal to total memory allocation of array. Okay, that's just like every single bit that just have to be done. So put it in simple word. Okay, sorry. Put it in simple word is mean that if you gonna declare one array, you need to have size of it, you need to have the data type of it, then compiler gonna store only the first address and then allocate the memory size at the equivalent space equal to array size multiplied by the size of data type. Okay, if here is integer and it's equal to 2 byte, and this is the size of 10, so the total memory allocation should be 20 bytes in total. Okay, in the same times, you can do something like two-dimensional or three-dimensional or four-dimensional array. That's depend on the support of the programming languages that you have been used in that moment, in that particular times. Okay, in some languages it's limited to only two-dimensional or three-dimensional maximally, but in some languages it depends on how you declare it. Then you can have like maybe 10-dimensional array. It depends on how you handle the code. But in concept itself, the way it's work is normally it's represented like this, right? Like a table. Okay, and you might have the number of column equal to y and the number of row equal to x. But put it in detail, okay? Put it in detail how RAM or how the memory store this data. How it's gonna be declared this data in your array. Okay, that's gonna be one thing that we need to talking about. So basically it doesn't store in this visualization image. Okay, this is misleading images, but it's easier to, you know, like teaching people like this, that okay, it look like matrix or it look like table, and then you can access it with x and y. But what happened itself is allocate. Okay, this one gonna contain only the one pointer if it is the C languages. Okay, and this one pointer point to the starting point in the memories, and then you're gonna create X sequential okay size. Okay, it might look like this. Okay, for example, it's gonna create the memory size of y, many of them. Okay, this one until this one gonna be y as well. This one until this one gonna be the size of y as well. Okay, but how many repetition is gonna create is equal to the x number itself. Okay, it's gonna be 1 repetition, 2 repetition, 3 repetition until x repetition. That's the ideas of how it's work. So basically it's one long array, but it chunked down into 2 or 3 different array in itself. Okay, that's what happened in C. I need to remind that this one is C languages. Then later on in C++ or in C# or even in Python, in very first version of Python, how it's handled data is changed like drastically. So they might say like, this one doesn't provide the flexibility of how we're gonna allocate the memories, especially like nowadays that we have a lot of data stored in RAM at the same time. So the way it does is create the array size of x. This one is gonna be C++, C#, or Python, but this one is like very old Python, because nowadays it's changed again. Okay, so what happens is it create the first array. Okay, the pointer, they still use only one pointer. Okay, one pointer point to the starting the memories of this array, and then is create the array of size x first, Okay, this one is equal to x, which is each of them store the address, which is starting point in the memories that allocate the data that have the sequence block equal to size of y. Okay, now you have more flexibilities that in RAM it doesn't have to be one big chunk of memories, but it, you know, like it look quite similar to pointer in many sense. So you have one array of address equal to size x, and then it automatically refer to each memory, each point in the memory that allocate the data of size y. This one create more flexibilities in the data itself. However, this is not like the common way in the concept of array at all. Since these 2 or 3 languages is much more high level languages in comparison to C, I might not call this one as a generic multi-dimensional array, but you need to keep in mind that the worlds nowadays change quite a lot, and then you can find this kind of solution in many high level languages. Okay, so we come to the problem and limitation of array itself. So first of all, since it's a sequence of the data that you create predefined, whenever you assign the data into array and you want to insert the memory in some specific index, you're gonna have quite problem and troublesome. So the solution that people gonna be done, and mostly they do it like this, is they create another array. For example, like this one called A. So they create array B equal to the size of A first, okay, and then they run for loop to transfer the memories, the data in A to B, okay, until it reach the index that you want to insert the data. Then you insert this one in, okay, then you keep copying the data in the other index until you finish. So you can see that the limitation of array is that since it's very fixed archetype of data, that you predefine the size of the sequence, in the same time that it like pretty small size in terms of like how big it is in comparison to linked list and how fast you can access in the memories. Array is gonna be much faster in most of the times. However, it's gonna have problem whenever you're gonna insert, whenever you want to insert the data, since you cannot immediately cut this memory down. You cannot break it down, because what happened is whenever you broke this one out, okay, you have only this pointer, but you don't have the pointer point to this block of memories, so you're gonna lose it mostly like all the times. Or people might say like, okay, I can keep the space a little bit if I use array C, that basically the copy of the tail of this one first, and then I clear the data out. I insert the value first, and then I transfer the data back from this memory, and I transfer the memory from this one back. You can do that. It's gonna be a little bit safe of the space, but it's not gonna be remove the troublesome that array have with the insertion. Okay. Next thing that you're gonna find for sure, if it have the problem with insertion, then it should have the problem with size adjustment as well. So basically, in C languages, it's impossible for you. It's impossible that you can delete like the size from 10 to 9, or you're gonna resize from 10 to 20. Basically, what you can do, okay, what you can do is you need to create another array. Okay, if you have a of size 10 and you want to resize it to be a of size 12, then the only way that you have to do is you need to create the buffer first. You need to create temp that copy all the data from array A, and then you create resize A to be 12, then you transfer from temp to A. That's the only way you can do. Okay, if you want to delete the data as well, if you want to delete the cell of the array as well, the only thing you can do is you recreate another array and then you clicking it back. You might say like, okay, I can do dynamic array with malloc and callocs, which is we're gonna talk later on, but in some sense, dynamic array that you say, the only way that you're gonna resize it is you malloc another space that's small enough equal to the size that you want before you transfer the data in, right? So in the same time, it's like, okay, I'm not create the temporary array, but I still have to malloc the space in the memory equal to the temporary array first to transfer the data in and then copy it down. Then it means this problem cannot be avoided at all in array. Okay, that's the problem that you have to keep in mind whenever you use array. Even though it's fast to implement, even though it's extremely useful, small, and match well with all of the algorithms, and most of the time people can use it, you need to keep in mind that this data shouldn't be inserted in most of the sense, shouldn't be deleted out in most of the sense, and also the size shouldn't be adjustable. Rather than that, then you're gonna encounter with this memory how it look like a memory duplication problems whenever you're gonna do deletion, insertion, or size adjustment. And it's gonna be really troublesome if your data is big enough. For example, if you have the DNA file, for example, you have human genomes, and the size of human genomes normally is around 200 megabyte, around that, for one sequence of genomes. And if you like want to resize the data structure that contain the human genome to do the deletion or insertion of the base pair, the problem is you need to like made the temporary space in RAM for another 240 megabytes before you transfer it in. That's not gonna be good. Okay. Especially if you like work with a big project like human genome project that you run the DNA sequence of like 100 or 200 people at the same time. That's not gonna be useful at all. Okay, so please keep in mind, you should use array whenever it's possible, because it's fast, because it's easy to implement, because it's extremely good data structure. But if that data should be insert, should be delete, should be resized, then you should consider to use something else, not array. That's pretty simple rule of thumb. Okay, then this is the end of this episode. Then we're gonna come back with the linked list, and also I want to mention something that we call list and array list, which is you're gonna be found in database languages nowadays, and also in high level languages like Python, R, or Ruby on Rails, that they change the way they handle the data. Now you're gonna encounter with the word array list in in the modern day form, and I think I need to mention it, how it's different from array, how it's different from linked list. Okay, I would like to keep push up this kind of content out to YouTube, and if you think it's too long, or if you think the way I use PowerPoint and setup for the video should be improved, please comment below, okay, in the Facebook groups, and it's gonna be helpful for me as well to adjust the way I done the lecture video and also the way I use this pen and I don't know, the PowerPoint and working space. That's gonna be more comfort for you guys and help you in the learning process. Okay, that's all for today. I'm talking so long. Thank you and bye bye. See you.